Today's lesson is relating graphs to input-output machines. We've done a bit of this already this year, so it should be a review. Let's look at this input and output machine. We have whatever number here is the input, and then we do this function to it, times 2 minus 1. And then what would come out would go here. So let's look at it. 1 times 2 is 2, minus 1 is 1. Great. 2 times 2 is 4, minus 1 is 3. Now what? 3 times 2 is 6, minus 1 is 5. 4 times 2 is 8, minus 1 is 7. 5 times 2 is 10, minus 1 is 9. You should also notice that there's a pattern going on here. It's increasing by 2 each time. When we're talking about an ordered pair for graphing, the input is always x, the first number, and the output is always y, the second number. So if we were to make these into ordered pairs, the next one would be 3 and 5, 4 and 7, 5 and 9. Then once we have the ordered pairs, we could graph them, and that is what you will be doing a lot of today. Let's look at this one. In this one, they don't tell you what's in the input and output machine, but they do give you the input and the output. So basically, you start with the 2, you do something to it, and then when you're done, it ends up being a 2. Interesting. You do something to the 3, and when you're done, it ends up being a 5. Well, we talked about this earlier this year. How do we find what the input-output machine would be? Well, the clue is to look in the output and see what you notice. Do you see any type of a pattern going on here? Think about that for a second. You should have noticed that it's increasing by 3 every time. When you notice that it's increasing by 3 every time, it gives us a clue for our first part of the input-output machine. And it's not plus 3. Does anyone remember what it would be? It's times 3. Okay, so now let's look at it again. 2 times 3 is 6. But we know when it comes back out, it has to be 2 again. So we're missing something. 2 times 3 is 6. We have to do something else to make it become 2 again. So what do you think that's going to be? Let's try it. Minus 4. Now, we always check it with at least 2 of these to make sure that it makes sense. So let's try it. 3 times 3 is 9. Minus 4 is 5. It worked. 4 times 3 is 12. Minus 4 is 8. It worked. Now, we're going to put the ordered pairs so that we could graph this. Input number is 2. The ordered pair would be 2. Output number is 2, so 2 and 2. Next one, 3 and 5. Next one, 4. Always put the brackets around it. Whoops. Next one, 5 and 11. And the last one, 6 and 14. So that's what you do if they are asking you to fill out the input-output machine. This is how you figure it out. First thing you do is see if you notice a pattern in the output. If you do, it gives you a clue up here. And then you go back to the original. You try it. 2 times 3. figure out what else you have to do to get this proper output. The last type of question is when they give you just a graph and you have to find the input and output and the function in the input-output machine. Well, how in the world are we supposed to do that? Well, let's look at it carefully together. Here, our input is x. I noticed I put x up here and y here. So on the x-axis, when we have 1, we have 2 on the y-axis. So let's look at that. So we have 1 here. And 2 here. Next, let's look at it over here at the graph again. When we have 2 on the x-axis, we have 5 on the y. So 2 and 5. Okay, next one. When we have 3 on the x-axis, count up here, we have 8 on the y. So 3, 8. Oh, that one went way over. That's okay, doesn't matter. Next one, we have 4 on the x-axis. We have 11. So 4 and 11. Now, when we look at this, we now have to figure out what the input and output machine would be. So we have our table. In every single question, you have to make a graph, a table, and an input-output machine. So just keep that in mind. Every question needs a graph, a table, and an input-output machine. Sometimes they give you the graph and you have to do the other two. Sometimes they give you the input-output machine and you have to do the table and the graph. So every question you'll be doing 2 out of the 3 things depending on what they give you at the beginning. So how do we figure the input-output machine? Let's go back here to my pen. When we put a 1 in, we're going to do 2 functions to it, and out is going to come a 2. Now, we could just say plus 1, but it can't be that because there's 2 different things. All right? So let's look for patterns in the output. Remember, that's how we figure these out, is we look for patterns in the output. So see if you notice anything going on here. It goes from 2 to 5 to 8 to 11. Okay, it's plus 3, plus 3, plus 3. Now who remembers what I said? If you notice it's a plus 3 going on in the output, what does that tell you about the first function? Is it going to be plus 3? No, it's going to be times 3. Okay. Now we take our numbers and we go back. 1, put it into the machine, times 3 is 3. Something else is going to happen to it, and when it comes back out, it's a 2. So what is that something else going to be? 1 times 3 is 3. Do something else, and it becomes a 2. Let's try minus 1 and see if that works. Try it with another one. 2, put it in. 2 times 3 is 6. Take away 1. Look at the output. Is it 5? Yes, it is. Next one. 3 times 3 is 9. Take away 1. Is the output 8? Yes, it is. So we've discovered from just this graph, we figured out how to make the table and then how to make the input-output machine. That is all you need to know. I will tell you on page 387, the last question, it's a bit of a different graph because the numbers, instead of increasing, they're going to be decreasing. So just keep that in mind. It doesn't change the way you do it. You still put the output the same way. You still put the input the same way. You still graph it the same way, but it's just going to look a little bit different. Hopefully this has been helpful. If you need any more help, come to the meeting at 11. Bye-bye.